Hello, my name is Niklas Hjert, and I will give you a short demonstration of Water in Europe Today, which is a web application developed by the Swedish Meteorological and Hydrological Institute for the switchon project. Well, what does WET do? WET visualizes data from any hydrological model. For now being it's EHYPE, a hydrological model of the European continent, developed by the SMHI hydrological group, but really any hydrological model with open data could be visualized. The purpose of WET is to give the user an understanding of how the current and forecasted discharge relates to historic discharges for any specific point in Europe. The application has two components. It has a map component, which is what you see when you open the application, and it has a diagram component. So the first thing you need to do when you enter the application is to choose your area of interest. You do that by zooming and clicking in the map. Let's go, for instance, we are interested in, well, let's say we're in Dresden. I would like to see the discharge at Dresden in the upper Elbe catchment. I click on Dresden, and what you see now is a highlight of the hydrological network upstream of Dresden. That is where the water comes from, but also it highlights the path of the Elbe down towards the Atlantic Ocean. And if you zoom out, you can see the coastal line and where the Elbe enters the Atlantic. Well, as you can see in this example, there is a lot of blue color in the maps, and the blue color means that discharge at a specific point is above normal or much above normal for this time of year. You can get some more information about this if you hover over the legend. You can see that the deep blue color means that discharge is above the 90th percentile for this date. If it's more of a light blue color, it's above the 75th percentile for this date. If, on the other hand, it's a red color, light red means below 25th percentile for this date, and the deep red is below the 10th percentile for this date. So what does this mean? Well, to explain more of this, we need to see the diagram. So click on Show Diagram on the upper left corner, just below the legend. Now, the bottom edge of the screen is filled with a diagram of the selected point of interest. In this example, it's Dresden. It shows you the current and forecasted discharge with a solid black line, and there's a thin vertical red line indicating the present day, the 5th of June in this case. In the background you can see some light blue shades, blue lines, and this represent historic discharges at Dresden. Now you can see that for most part the black line is quite far above the blue shades, which means that for now discharge at Dresden is higher than normal for this time of year. The normal range is calculated from discharges between 1981 and 2010. Now, if we're interested in other points in the catchment, either upstream or downstream of Dresden, we can just click on any of the points and you will get a new diagram plotted for that specific point in the lower part of the screen. You could also click downstream of Dresden to see the discharge in Elbe. And the last thing I wanted to show you here is the time slider, which is in the upper left corner just above the legend. The time slider makes it possible to switch dates in the map view, so you can actually step through different days in the forecast, and you see on the map that it's actually drying up. A lot of the blue colors are disappearing, and we are entering what seems to be a normal range at the end of the forecast period. Also, you can see that the thin red line in the diagram moves when you click on the time slider and you move the time slider. It actually shows the corresponding date in the diagram as well. Now, the last thing I want to show is if you're interested in another area, you can change the point of interest by either clicking Change Area in the upper left corner of the screen, or simply drag the flag with the mouse and releasing it on another area, and you can start investigating the flow in this particular area. Thank you very much.
The virtual water science laboratory is developed in Work Package 3 in the switchon project. The aim is to develop an environment that makes it easier for researchers to share discussions and results and data in hydrological experiments. In this presentation, we will give a brief overview of the main components of the laboratory. The two red rectangles in this picture represents the internal environment of two research teams. In their internal environments, they do have a lot of scripts and tools for experimenting and hydrological modeling. The green rectangle represents external data sources, which are frequently used by the research team to download data. In the presentation, we will show how the blue rectangle, the virtual water science laboratory, can aid the researchers to collaborate around the data and the experiments. To participate in a collaborative experiment, the researchers would need to initiate a discussion and initiate a protocol to record their experiment. For this purpose, the laboratory contains discussion support as email lists, forums, and storage for protocols. To promote repeatability and transparency, the collaborative experiments should be carried out according to agreed procedures, which are documented according to protocols. This will be identified in a collective effort of the scientific community to assure that they facilitate research and data sharing among scientists. There are currently identified several kinds of protocols in the project. When an experiment has been initiated, the SIP Expert Catalog provides a functionality for searching and finding and exploring data. The data in the catalog will come from 3 different sources. It could be arbitrary external data catalogs that are relevant for hydrological research, for instance GEOS or CORIN. It might also be experiment data from previous experiments in the virtual water science laboratory. And also for a research team, it's possible to enroll and link their own external data sources and make them visible in the SIP Expert Catalog. When a dataset has been identified, the researcher can further explore its properties to decide if it's adequate for use in the experiment and download the relevant dataset. The laboratory can also contain functionality for basic visualization and exploration of model results and new datasets. To further aid the user to explore the data, the Virtual Water Science Laboratory contains an aim for storing manuals, instructions about data, models, and other tools. It is also possible to upload program code to the laboratory and thus enable teams to share their scripts and tools used in different experiments. Once the interesting components and data sets has been identified, the user can download them into their own internal environment and run the experiments in the usual way and see what results they get. As soon as there are some interesting results, the research team can publish the results in the virtual science laboratory, either in the experiment data repository, or they can also share their codes for scripts and different scripts and tools, or they can also publish their data in spatial services or time series access functionality that they have in the local environment. Scientific paper and technical reports resulting from collaboration experiments based on data in the laboratory will be posted to be accessible in the laboratory. Published papers can be uploaded here to record or recorded via a link to the publisher. This is also possible for any kind of technical report explaining or providing additional details to a scientific question, dataset, or model that can be uploaded here.
Hello, I'm Niklas Hjert and I'm going to give you a brief demonstration of the European Eutrophication Control, a web application developed by the SMHI for the switchon project. The purpose of this application is to provide an analysis and scenario tool for eutrophication of inland waters. The application visualizes nitrogen and phosphorus transport calculations by the EHYPE hydrological model. These calculations will reveal the sources of nitrogen geographically and sector-wise for any point in a catchment. Now, the first thing that you need to do as a user is to define your point of interest. For this purpose, let's choose a catchment, for instance, in Italy. Let's choose the Lago di Como, just north of Milan. As I select this lake, a graph is highlighted on the screen, and you can also see a source apportionment on the right hand corner for Lake Como regarding the phosphorus transport. You can also switch to nitrogen, and you can see the source apportionment for nitrogen immediately. Let's go back to phosphorus. Now, what the graph in the map is showing is the relative contribution from each of the catchments upstream of Lake Como to Lake Como. So each of these circles now defines the accumulated load of phosphorus at this specific catchment. So we can see here that quite a lot of phosphorus is coming down River Adda in the northern part of the lake. We can also see the total sources, total phosphorus load at the outlet of Lake Como. The pie diagram in the right hand corner is showing us that the biggest contributor to phosphorus in Lake Como is the agricultural land. We can also select agricultural land on the left hand corner, and we can see the relative contributions of load from agricultural land to Lake Como. We can look at other sectors such as rural households, wastewater treatment plants, industry, and urban areas. Let's go back to all sources and just look at the second choice. You can actually choose what load to visualize. The current load is the accumulated load in each part of the catchment, but if you switch to the local net contribution to the point of interest, you will see how much each of the catchments is contributing to Lake Como. Okay, let's switch back to the accumulated load. And now let's think about measures to reduce the phosphorus load on Lake Como. Imagine, for instance, that we can plan a measure somewhere on River Adda to reduce the phosphorus loads on Lake Como, and we can test this by clicking on one of the catchments in River Adda, and we can see here that River Adda is yielding 130,242 kilograms per year to Lake Como. Let's say that we can reduce this in some magical way by 50,000 kilograms. So let's type in minus 50,000. Now you can see that the outlet figure is much reduced. It's now to 80,000 kilograms per year. And you can also see that in Lake Como, this actually means a 17.71% decrease in phosphorus load. Please note that you don't have to tell exactly what kind of measure you're doing, just the result of this measure and how it's affecting the point of interest. You could also enter other scenario or other measures. For instance, here we may be able to reduce the load by minus 10,000, and up here we might be able to reduce it by 2,000. What you can see now is all of these scenarios together will give a minus 21.96% decrease in Lake Como. I should add that you could also simulate an increase in load. For instance, if someone is planning building projects or golf courses in the catchment, this figure of minus 10,000 might turn out to be plus 10,000. So you can add 10,000 kilograms and you can look at the resulting load on Lake Como. And you can remove the scenarios by just clicking out the boxes, or you can mail the scenarios to someone else by choosing the link and then copying the web link and mailing it or sharing it with someone else. One last thing is that this is a highly interactive tool. You could also move the point of interest easily by selecting the flag and pressing your left key on the mouse and just dragging it to another point. And now you will have analysis of the source apportionment for this point, and you can see to the right hand corner what the circle diagram or the pie diagram is telling you about the sources. There is also a filter function which allows you to remove points that are not interesting for some reason. You can remove the small catchments with small contributions and to focus on the catchments with the larger contributions. Well, that's all for now. Thank you very much for listening.